Welcome to This Explainer. Today, we're taking a seriously fascinating journey into the unbreakable engines that are quietly powering the future of continuous AI workflows. We spend so much of our digital lives staring at highly polished screens, but beneath all of that visual polish lies a foundational reality that most of us completely ignore. We're going to look past the superficial layers of modern software to really understand the pure, uninterrupted stream of text that actually commands the machine. We'll be uncovering how tools like GNU Screen and the pseudo-terminal, or PTY, allow us to operate with absolute precision and zero data loss. It's a fundamental shift in how we think about computing, authorship, and artificial intelligence. To really understand why this matters, we have to start by asking a critical question. Think about your day-to-day workflow for a second. What happens to a complex task or an AI agent running in the cloud when your internet flickers for just a single millisecond? You probably already know the painful answer. In the fragile reality of modern web browsers, an API drops, the page violently refreshes, and poof. Hours of intricate work, context, and generation can be lost instantly. It's incredibly frustrating, and honestly, it exposes a massive vulnerability in how we currently interact with our machines. We are basically building the future of automation on a foundation of sand. There's a pretty stark contrast between two totally different computing worlds here. On one side, we have the graphical user interface, or GUI. The web browsers we use every single day are incredibly heavy. They require massive computational power just to render visual illusions, drop shadows, rounded corners, smooth animations, and they're incredibly delicate. On the other side, we have the command line interface, the CLI. This is streamlined, unmediated reality. It's lightweight, and it generates 100% exact text locks. Instead of talking to a bloated visual layer, the command line allows us to communicate directly with the machine's hardware. I absolutely love this quote from the source material. It's from legal scholar Eben Moglen, and it just perfectly captures our modern interface problem. It goes, "We get the chimpanzee hitting buttons, but we chat with each other. We could be hitting buttons, but it isn't as good." It's funny, but seriously, think about that for a second. The GUIs essentially reduce us to animals pushing colorful levers for a quick dopamine reward. But human beings are built for deep, nuanced language. We write, we debate, we chat. Forcing us to click pre-drawn buttons actually dumbs down our ability to express complex, nuanced thoughts to our computers. We trade the rich composability of language for a shiny button. So how do we solve this interface crisis? Well, here is our roadmap. Number 1, the fragile graphic interface. 2, hardware roots of TTY. 3, the pseudo-terminal pipeline. 4, GNU screen isolation. And finally, 5, the unbreakable AI agent. All right, let's dive right into section 1, the fragile graphic interface. Let's unpack why relying on these visual layers for serious AI automation is ultimately a dead end. When we try to get AI to automate tasks on standard graphical systems, it usually turns into a total mess. Because the GUI wasn't built for machines, it was built for human eyes. So developers have to resort to super fragile techniques like screen scraping. Basically, the AI takes a messy, pixelated picture of your screen and just guesses what to click based on shapes and colors. It's this invasive layer of translation. And here's the real kicker. If a website changes its layout, even slightly, like maybe a button moves 2 pixels to the left, bam, the whole automation breaks instantly. It introduces endless errors and slows everything down. It's just not sustainable. Which brings us to section 2, hardware roots of TTY. To find the real solution, we actually need to look backward to the physical history of what researchers call the universal interface. Pure, exact text running on a teletypewriter, or TTY. Before we had screens, we had these incredible electromechanical typewriters that transmitted text over telegraph wires using raw electricity. This archival diagram here, the 7.42 unit code time base, shows exactly how a letter, in this case the letter Y, was broken down into physical electrical pulses. It functioned on a system of mark, which meant current was flowing, and space, which meant the current was interrupted. This is the literal physical mechanics of text. Text is fundamentally electrical resistance and voltage, directly mapped to human language. So, the truly crucial point here is how this physical mechanism guaranteed accuracy without a centralized clock. They use something called start-stop synchronization. A starting mark pulse would literally trip a physical clutch on the receiving teletype machine. That would release a cam sleeve to rotate and read the incoming electrical pulses before a stop spacing pulse reset the whole system. It was an uncompromising current loop. It ensured the exact, uninterrupted transmission of every single character. If you typed in A, the machine physically locked in the electrical state for an A. There was no guessing, no screen scraping, just 100% deterministic execution. That amazing physical hardware history perfectly bridges into Section 3, the pseudo-terminal pipeline. This is the modern digital equivalent powering the core of today's systems. We need to clearly define what a PTY, or pseudo-terminal, actually is. Think of it as the uncompromising back-end channel for continuous communication. It's a direct text-only pipeline straight into the arithmetic brain of the machine. Because it operates entirely on explicit text characters, just like those old electrical marks and spaces, it enables perfectly lossless input. When an AI agent reads from a PTY, it receives mathematically pure text. It doesn't need to decode graphical interfaces or guess what a button does. Furthermore, the PTY logs the exact history or provenance of every single action taken. Nothing gets lost in translation. And this introduces a profoundly beautiful concept from the source material, the semiotic bridge. Think about how totally alien we are from our computers. Our human cognition, what researchers playfully call OS alpha, is beautifully fuzzy, associative, and highly creative. We think in feelings and fluid context. But the computer's processor, the arithmetic logic unit, or ALU, is totally cold, rigid, and driven entirely by strict electrical voltages. It is utterly blind to our intentions. So how do we cross that massive gap? The answer is text. Strictly formatted text acts as the semiotic bridge. It is the only deterministic medium that can safely compile our messy human imagination and intent directly into exact physical hardware execution. Now that we understand the power of that text pipeline, let's move to Section 4, New Screen Isolation. We are going to look at the ultimate backend tool that leverages this pipeline to protect our work, GNU Screen. It's basically a terminal multiplexer, and honestly, it is absolute magic for long-running workflows. Let's walk through this unbreakable cycle. You start by launching your AI agent inside a GNU Screen session. From there, you simply issue a command to detach. The process just keeps running seamlessly. You can completely disconnect your network, close your laptop, and walk away. The AI agent's context loop will continue running safely in the background on the remote server for days. Then, when you're ready, you come back and reattach to that exact session with absolutely zero data loss. Unlike a web page that just refreshes and dies the second your Wi-Fi blinks, these teletype channels act as fully sovereign, isolated environments. The source material emphasizes that these channels act almost as isolated, highly secure users on the operating system. You're completely protected from the fragile whims of the front-end internet. GNU Screen creates a mathematically certain, unbreakable environment for remote AI agents to operate safely without constant human babysitting. And that brings us directly to our final section, Section 5, the unbreakable AI agent. Let's connect this unbreakable back-end infrastructure to the future. Operating via text on a PTY within a tool like GNU Screen unlocks some literally incredible capabilities. First, as we noted, your AI context loops can run safely for days uninterrupted. But more importantly, it preserves what the sources call the magic of authorship. Because we're using exact lossless text logs, we have perfect traceability. We can trace exactly where an idea came from, when it was generated, and whether a human or a machine contributed to it. The system uses unique session IDs and spell chains to create an unbroken chronological record of human thought and machine response. This matters immensely because it means we can cryptographically protect our trade secrets locally. The exact provenance of the data, who created it and when, is undeniably protected. But AI isn't perfect, right? It's probabilistic, which means it guesses, and sometimes it guesses wrong, creating what the sources call an automated miasma. This is where the human pilot comes back in. Because the entire system is built on an accessible text substrate, a human can step in and perform substrate pruning. This means you roll up your sleeves, physically edit the text, and confidently override the AI's continuous guesswork. It demands the sweat of the brow. This explicit text intervention acts as a hard separation between human intent and machine execution, forcing the AI to behave predictably. You aren't just trusting a black box. You're securely controlling the system at the absolute source. So, we've traveled from the heavy, bloated illusions of the modern web browser all the way down to the electrical hardware roots of the teletypewriter, and back up to the absolute sovereignty of the unbreakable AI agent. The command line isn't just some archaic tool for hackers. It is the fundamental semiotic bridge that translates your imagination into physical reality with perfect fidelity. Now that you know the graphical interface is really just a fragile layer holding you back, and that pure text on a PTY is the ultimate, unbreakable, universal interface, how will you write your own future at the speed of thought? Thank you so much for joining me on this explainer, and I'll catch you next time.